All right, so let's pick up where we left off last time. We went over sex-linked inheritance, and we'll do a little bit more with it. So this is a cat. That's a big scientific discovery right there. So this is a calico cat, and we're going to go over calico cats today. Calico cats are ones with orange, black, and white fur. There's also tortie cats or tortoiseshell cats that are just orange and black fur. But anyway, so here's a grown-up calico cat, and we're going to do an example with calicos, okay? So for calico cats, we're going to talk about their fur color, and it is actually a sex-linked inheritance trait. So we can either have black or orange fur. And this is a type of sex-linked inheritance that is codominant. So let's talk about boys and girls here. We're talking about cats, not people, obviously. But we'll do female cats in red, and I'll do male cats in blue. So we know males, we're going to have XY. We're going to have two genotypes there. Females, XX. Whoa, I got real big. Sorry, guys. Let's move me out of the way here. There we go. I am sufficiently moved out of the way. All right, so it's codominant, so we're going to have two capital alleles. So I'm just going to use B and O, B for black and O for orange. I know O, I talked to you guys about the past and using different letters. I know capital O looks like lowercase o, but we're only dealing with capital, so it really doesn't matter. So females, they could be big B, big B. They could be OO, or they could be BO. So if they are big B, their fur color is going to be black. If they are OO, their fur color is going to be orange. If they are BO, they are going to be that calico color where we are going to see both of the phenotypes. We're going to see black and orange. Let's go over to the males. Remember, guys, the Y does not have any alleles on it. So X big BY, it's going to be black. XOY, it's going to be orange. Okay? So moral of the story, guys, is only females can be calico. There are no calico cats without a genetic condition out there. Okay? If you see a male calico cat, something happened where it has an extra chromosome. It's going to have one extra because it's going to be XXY. All right? So that's the only exception for it. But normal cats with a normal amount of chromosomes, if they are calico, 100% chance they're going to be female. All right? So I just want to go over that example with you guys before we moved on to pedigrees. Okay, this is our last little bit of our chapter on genetics. We're going to go over pedigrees. And what a pedigree is it's pretty much like a family tree. And it's going to show us different conditions that are in a, family tree in a family. So here's how we are going to show who is who. Males are always going to be squares. Females are always going to be circles. If a male is affected by a condition or a female is affected by a condition, they are going to have their square or circle filled in. Sorry for the bell. If we have a line drawn between a female and a male, that means they, now today's day and age a little bit different, but there is a marriage there and they're going to have some kids, okay? So they had kids. Now, if you look here in this little thing, we are going to start with the oldest child on the left side. So oldest is over here, and we're going to go to the youngest on this side. These two got married and they had 5 kids. Let's say if the oldest got married and had a kid, we want to draw it like this, and then we would draw the male over here. That does not make the male part of these two kids. That wouldn't make much sense. Also, going from that terminology, we never want to do this. Okay? These are both of their kids. We do not want a line going between them. That's very bad. All right? So, none of that. If you want to draw a marriage between someone, it cannot be connected to these two. All right? So, here's a pedigree for you guys. You could see that we have a bunch of different generations here. What you will see is on the side, you're going to see Roman numerals. That's generation 1, generation 2, generation 3, and then down here would be generation 4. Okay. In these different generations, you can see only 3 individuals are affected. That female, and that male, I don't know what the condition is, but they are affected. Everyone else is not affected. Okay, we already went over that one. Here is one that is inherited dominantly. Now, we can inherit some things dominantly or recessive. Autosomal just means it's not on our sex chromosomes. We do not have to worry about doing the X and the Y's if it says autosomal. Okay? Now, if you look here, how can we determine this, that it's autosomal dominant? So this means that the filled in ones, if they're filled in, that means they are either going to be big R, or big R, little r, because it's dominant. Okay. How we can prove that it's autosomal dominant is do the opposite. Do autosomal recessive. If these two here are both little r, if it is autosomal recessive, you do the Punnett Square, all of the kids in there, I'm not going to do it all, but all of these would be little r. If you look, they had 1, 2, 3 kids. This one here, there's no way that they could not be affected if this was autosomal recessive. That's how we know it's autosomal dominant. Okay? All right. So here's a few questions. Whoops, went too far. Here's a few questions for you guys. Is the mom or dad affected by trait in generation 1? Okay, obviously that's the dad. What is the genotype of the first offspring in generation 2? The first offspring in generation 2. Now, I said we're going over autosomal dominant here. Okay, so if they are filled in, they're going to be big R, little r. So individual number 1 of generation 2 right here, this square, he's going to be little r. What's the genotype of the second individual in generation 2? That's this one. And we know it could be big R, or big R, little r if it's filled in. So let's try Punnett Square, knowing in generation 3 here we have 1, 2, 3 offspring, and 2 are filled in. So if we said number 2 is big R, number 1 is little r, all of the kids would be big R, little r. What this means is that number 1 down here would have to be filled in. But it's not. Since it's not filled in, we know that this one up here, number 2, has to be big R, little r. And that will allow us to get that little r out of it right there, or right at the bottom. Okay? All right. So we kind of went over all that already, guys. with autosomal dominant. I think we're good there. I think we're good. Okay. So recessive pedigrees. This is where the filled in ones are going to be little r. So for our pedigrees, these are a little bit easier for the recessive ones to see than the dominant ones. Let me show you right here. Get myself out of the way. So we know that if it's filled in, we know that for a recessive one, it is little. Okay? If we have two of our parents filled in, if we had both of them filled in, every single kid would also be filled in. Now, there's no parents here where both of them are filled in, but yeah. But if you look here, number 1 in generation 2, that would have to be big R, little r. Number 2 would have to be little r, and that will allow some of these kids to have that little r genotype. All right. So that's what a recessive one looks like. Every now and again, guys, and these are very nice if they give it to you. Usually they don't, but every now and again you get one. Sometimes they're nice to you. In generation 3, you see these ones here, number 1 and number 2. What that means is they are a carrier. That means they are going to be big R, little r. Okay? This would be little r. This would be big, probably big, I'm guessing, since both of the kids are big R, little r. All right? Number 1 would be little r. That would be big R, little r. But just a different way to do it, and it's kind of nice because you guys can see all 3 genotypes on this one. All right. And we don't have to go over the questions, guys. I think we're good on that. These ones are pretty easy whenever they give you that. Sex-linked pedigrees. These ones are a little bit tricky, but if you look for one thing, they're very easy. Don't forget in sex-linked, the males are going to have this trait more often than the females. Since the males are going to have it more often, we're going to see more males affected in these sex-linked pedigrees. So if you look at this one here, females, even though they're half filled in, they don't have the trait. If you look here, look at the males. The males are filled in. There is no females that are fully affected, but there are 2 males. That's how you tell X-linked things. You're going to see more males affected if it's recessive. This one is dominant. I don't think you'll ever see a dominant one, guys, meaning if it's X big R, they're affected. Usually they do the X-linked recessive, and it makes it a lot easier for you just because you just look at the males, and if there's more males affected, you know it's X-linked. All right, guys, we'll have some practice to do on pedigrees, and that'll be pretty much it for the chapter. So we'll do that, have some practice over it, go over it, play the review game, and then we'll have our test in the next few days. Have a good rest of your day, guys.